So for the second part of the package, when you check the exactness, so when we have m x y dx plus n xy dy equals 0, and then when you check the exactness, the partial m with respect to y not equal to the partial n with respect to x. So that means it doesn't start with the exact form to begin with. Then we're gonna find the integrating factor. Okay, integrating factor, or the IF, integrating. We use integrating factor when we did the linear equation last week. The integrating factor, basically when we get it, we multiply the original equation with all terms, and then the integrating factor will help you find the product of the functions in the form of the derivative. So therefore you can find the antiderivative and get the solution out. So that was back in linear equation form. So to find the integrating factor for the exact equation, so we're gonna use whatever that we use the partial derivative that we use to check the exactness. So I'm gonna use the partial m with respect to y as m subscript y, and the partial n with respect to x as n subscript x. Okay, so the integrating factor, the same notation, we use the mu. This time mu is a function in both x and y. So the mu could be in the form of either like e to the integral of the m y minus nx divided by n with respect to x, or the mu in the form of e to the integral. I'll explain in a bit. Let me write this formula down. So nx minus my all divided by m dy. All right, how do we determine which one we're gonna use? So from the my nx, or the partial derivatives that you did at the testing process, if you put them as my minus nx, since they are not the same, you subtract them, they will not be 0. So the numerator here will be non-zero term. So if we set my minus nx and divided by n, and it's totally the function in x, okay, so I put here as a function in x, the g of x. After you simplify completely, it has to be just terms in x or the constant term. Okay, for this case, you're gonna use mu in this form. You see, integral with respect to x, function in x. If it's not totally in x, you're gonna try another version by switching the order of the numerator by setting up nx minus my. And now this time we're gonna divide by m. The terms, if it turns out to be totally function in y, you're gonna find the mu, or the integrating factor, using this, the second case of the formula. All right, it's kind of confusing, right? So here's the tips. You have to check this step no matter what. Okay, no matter what. Start with one way. If you subtract them, whatever way that you start, and you see the relationship here, you subtract it by nx, you divide it by n, and that term must be in terms of x. The simplified form must be in terms of x. If it's not, swap the order. When you swap the order, sorry, again, you subtract it by the m group, so you divide by m. The simplified form must be the function in y. You see the notations? And this is the way that I recognize and to help me out to set up whether it's with respect to x or with respect to y. Okay? It's confusing. And after we get the mu, we're gonna multiply the original non-exact equation by mu, every single term. After that, you should get the exact equation to find the solution for. Okay? Now I'm gonna use the system. So the next example, let's do the example one. I kind of started the process in the package to help you see the big picture of the non-exact and how to find the solution for this case. So the quantity xy times dx plus the 2x squared plus 3y squared minus 20 times dy equals 0. So your m, which is x times y, and your n is 2x squared plus 3y squared minus 20. Check the exactness by finding the partial with respect to y for the m or the my, okay, m subscript y. The partial with respect to y is the x, and for the n, find the partial n with respect to x or the nx is 4x, and the rest of the term give you the derivative 0. It's very obvious they are not the same, so not exact as the original differential equation that's given to you. Now to find the integrating factor, you're gonna start with one way or the other. Again, it's your preference. If one way doesn't work, you try the other way. So it doesn't hurt, it's just 50% chance. If your first case works, okay, we're good. So move on to the next step. So by trying, if you start with the my subtracted by nx, you see I subtracted by n. I'm gonna divide by n, okay? N here. So my my is x, my nx is 4x, and this has to be divided by the expression of the n, or 2x squared plus 3y squared minus 20. After you simplify, you would get negative 3x over 2x squared plus 3y squared minus 20. But we are expecting to get this totally in form of the x, but it's not because the denominator is in the combination of the x and y. So this way doesn't work. Okay, doesn't work. Now we're gonna try another version by swapping the nx and my. Switch the order. So nx minus my. If you subtract by my, you're gonna divide by m. You see m and m here. Okay, so your nx is 4x, my is x, divided by the expression for the m, which is x times y. Simplify completely. So we have 3x divided by x times y. Now we see x and x reduced with 3 over y. Bingo. We have this as the totally function in y. Okay? And then what? We're going to use this to find mu. Okay, to find mu. So since the nx minus my over m equals 3 over y, or the function in y. Okay, function in y. Oops. What did I do here? Okay, the function in y. So this time, the integrating factor will be found by mu equals e to the integral 3 over y. 3 over y with respect to y. See, if it is function in y with respect to y. So we have e to the power 3 natural log y. We can omit the absolute values to understood to be the positive term. Then this is the same as natural log of y to the third. So e to the log y to the third will give you y to the third as the integrating factor mu. Okay? And how do we use mu? We're gonna multiply the equation, the differential equation, the original differential equation by mu. Okay, by mu. That means from the xy dx plus the 2x squared plus 3y squared minus 20 with respect to y equals 0. We're going to multiply all by mu. And mu is y to the third and y to the third. And simplify the expression here to be x times y to the fourth times dx plus the quantity 2x squared y to the third plus 3y to the fifth minus 20 y to the third with respect to y equals 0. becomes your new differential equation, and this equation must be exact. Okay, how do you know for sure it's exact, or how do you know that your mu is the right term? You just check the exactness again, like what you did as the earlier part of the package. Okay, do the quick check. Now your new m is xy to the fourth, and your new n is 2x squared y to the third plus 3y to the fifth minus 20y to the third. Okay, quick check. So the partial m with respect to y would be 4xy to the third. Okay, and partial n with respect to x, you would get 4x and then y to the third. The last two terms will be 0. They are the same. So check. So you got the right mu, and now you have the exact equation to work and follow the same process as before by using the new set of the m and n to find the general solution. Okay. Which one we're gonna use, Mary or Nancy this time? Mary is one term. Nancy has 3 terms. I would go with Mary. It's less term for me to work on. Don't you agree? you feel free to use any one. So again, it doesn't matter which one. So we're gonna use the Mary. Okay. M is xy to the fourth, which is the partial of the solution with respect to x. So the solution fxy is the integral of xy to the fourth with respect to x. With respect to x, and then plus the constant of integration. We repeat the g and h all over the place, but in this step, the gy is the constant of integration, which in terms of the y. All right, so the integral of the xy to the fourth with respect to x would give us x squared over 2 times y to the fourth, which consider the constant or the coefficient, and then plus the gy. Okay, and since we already use m, the next part we're gonna use n. So the n must be the same as the partial of this solution that we just got with respect to y. So the n is like 1, 2, 3, 3 terms. 2x to the second, y to the third, plus 3y to the fifth, minus 20y to the third equals the partial derivative of these two terms with respect to y will give us what? 2x squared y to the third, I believe. Okay, plus the g prime of y. And now we're gonna find out what g prime of y. So 2x squared y to the third reduce, and therefore this is your g prime of y. Or g prime of y is 3y to the fifth minus 20y to the third. Okay, and I'm gonna add another page. Now your g prime of y. As we have g prime y equals 3y to the fifth minus 20y to the third, so we can find g of y as antiderivative of 3y to the fifth minus 20y to the third with respect to y. That gives us 3y to the 6 over 6, or 1/2 y to the 6 minus 5y to the fourth for the g of y. Therefore, the general solution is of the form fxy equals c, or 1/2 x squared y to the fourth plus 1 over 2 y to the 6 minus 5y to the fourth equals c.